So I feel comfortable with typing it into calculator and finding the math, but I was wondering if we could work on 67 to 78,
Sure,
mainly focusing on those.
sure. Yeah, these are good. These are good challenging problems. Okay. Um, so let's just do them in order here. 67 r equals 2 sine theta. So you know that x squared plus r squared equals r squared. And you know that x equals r cosine theta and y equals r sine theta. And tangent of theta is y over x. This is kind of all you have to go off of when you're working through this. Would you agree?
Yeah.
Okay. So this one's, I mean, they're all fairly messy. Um, like you could solve sine theta is y over r. Okay, so r equals 2 times y over r, like that. Is that clear?
Yeah.
And our goal is to get rid of r and theta. So we've done half of that. Now if you multiply both sides by r, you get r squared equals 2y. Well, what is r squared? R squared is x squared plus y squared equals 2y. Is
Hmm.
that okay?
Yeah.
And this is where it gets into, well, what does your teacher want? Well, I need to send off a message here. So you can move this 2y to the left. So we have x squared plus y squared minus 2y. And then you can complete the square here. So it becomes y minus 1 squared. You end up adding 1, adding 1. And this is your final equation.
And so would you just need to remember to add one or?
Yeah. So the process is you divide by 2 and then you square it.
Okay.
Is that okay?
Yeah.
Why don't you try 68? It's really similar. You're basically substituting in for, and these are the equations you need. You're basically substituting in for cosine instead of sine. Would you give this a try, please?
Okay. So it'd be R equals 2x over R.
Okay, good. So you're going to clear that r by multiplying both sides by r.
So then it'd be x squared plus y squared equals 2x, which would be,
Got to bring the 2x over and then complete the square on it.
Would it be x squared minus 2y? Oh, wait, no. Y squared minus 2y plus 1.
You're just bringing over the 2x, so you combine it with the
Oh,
you're completing the square on the one on the left here.
yeah.
You just take half of the middle number, divide it by 2, and then square it. So
But
you end up getting,
minus 1 plus minus 1 is minus 2.
yeah, but so if you were to expand this, you will get x squared minus 2x plus 1. If you were to
Oh,
FOIL that,
okay.
x minus 1 times x minus 1.
Oh, yeah, sorry. And then would I just leave the answer like that, or would I bring the 1 to the other side?
It's supposed to be on the right side.
Okay.
Okay, so we're gonna look at I'm gonna do 70. I'll have to get 69. So we're substituting for sine theta. Y equals r sine theta. So sine theta is y divided by r. I'm just substituting in like that. Any uh any idea what I might do here when you have a fraction within a fraction, complex fraction?
Um, you'd multiply with the other side.
Okay. Yeah, actually want to make a common denominator down here on the bottom. So it's 3 over r minus y over r. That's one way to proceed. And then it becomes 3 over r minus y over r.
So it'd be 3r over r minus y.
Yeah, you would figure it out. And so, yeah, you get r equals 3r over r minus y. So actually, so
Multiply both sides by r minus y.
yeah,
So it's r squared minus.
yeah, I'm gonna leave it out because we can actually cancel with that.
Oh, okay.
Um, problem is we don't have anything for r. Um, like we end up getting y equals r minus 3. R is the square root. R squared is x squared plus y squared. So r is the square root of x squared plus y squared. So I guess you get this. Now, maybe that's not the right way to go here. Probably they wanted you to do this. Well, yeah, okay, and maybe not. Let's go x squared plus y squared minus 3. So you could add 3 to both sides. And then you could square both sides. And sometimes I'm not sure where to stop these things, truthfully. So you may want to check with your instructor, but you'll notice that the expansion of this is y squared plus 6y plus 9 equals x squared plus y squared, which means that the y squareds cancel. And you can still solve for x or y. Sorry, you can solve for y. Y is equal to x squared minus 9 divided by 6. But I'm not sure where to stop, truthfully.
Have to grab. Oh wait. What problem is this?
This is number 70.
Oh, okay. because we do the odd ones for homework, so I was checking my homework. But
Okay. Well, why don't you, I was gonna have you do the other one, see if you had any questions on it.
can I see that problem again though?
Sure.
Can I see the answer? Okay, I think I would leave it as that.
So why don't you try 69? It is a little messy. Um, you know, it is the same steps. It's just a different look to it. Let me go ahead and snip that in.
I got to x squared plus y squared equals 2 minus y. And then
I mean, it's really very similar. It's 2/1 plus y over r. So it ends up being 2r over r plus y. So you get r times r plus y equals 2r. Is that what you meant?
I did different. I multiplied both
Okay.
sides by 1 plus sine theta. So I got r plus r sine theta equals 2, and then r equals 2y, I mean 2 minus y, which equals x squared plus y squared equals 2 minus y.
Let me try that. So you got r plus r sine theta equals 2. Now this is y, correct? So you got r
Yeah.
plus y equals 2. Okay. So from here, I mean, the only thing you really got left is that x squared plus y squared equals r squared. So r is the square root of x squared plus y squared, like that.
Okay, yeah.
And then you can move the y to the right, which I would do. I'd move the y right and then square both sides. You should get a parabola when you're done.
But would I leave the answer as though,
Well,
would
like I
I?
said, I would subtract y from both sides and then square both sides.
So then x squared plus y squared
Yep.
equals
And you gotta multiply that out like it's a binomial times a binomial.
y squared minus 4y minus 4.
Yeah, plus 4.
And then it would be x squared plus 4y minus 4, which would be x minus 2 squared equals 0.
You're solving for y now. You can always do that. You can either leave that on the right side or move it to the left. But you're still gonna have an x squared. You want to try that one more time? I didn't quite hear what your answer was.
It'd be x squared plus 4y minus 4.
No, no, you gotta solve it for y. When you can actually solve for y, you should do that.
Oh. So 4y equals minus x squared plus 4.
Right? And keep going. And if that's not solved for y.
So then y would be minus x squared plus 4 over 4.
Yeah. Any questions on that?
I don't think so.
Okay. You should notice kind of a pattern here that you're substituting in for, sine theta, cosine theta,
Yeah.
and so on. So again, so sine theta is y over r. Is that right? Yeah, that's right. And then
Mhm.
cosine theta is x over r.
Yeah.
Now you could choose to multiply both sides, which I think is what you would do here. Is that what you said you kind of tended to do? Like multiply both sides
Hmm.
by the 4 cosine theta. So it'd be r times 4 cosine theta minus sine theta equals 3 r, and then cosine is x over r minus y over r. Could you simplify this from here?
It would be 4x minus y equals 3.
Okay, and you solve for y whenever you can.
So you wouldn't solve for x in this case?
You typically solve for y. I mean, that's the most common letter to solve for.
Okay. So then y would be minus 3 minus 4x.
Nope. Nope. Are you ready? Are you working this out? I mean, you just gotta cancel out the r's, move the y to the right, or move the other stuff. Divide by -1.
If you left the y on that side and then multiplied both sides by -1, it would be minus 3 plus 4x.
Yes, correct. So that would work. Okay, and the expectation is that you will solve for y. All right, so we'll look at 71 together here. Tell me what to substitute for cosine theta and sine theta.
You can multiply both sides by r, so then it'd be r squared minus
What do that? What do you substitute for cosine theta and sine theta?
x over r and y over r.
Yeah, and then you can multiply by both sides by r.
And
You have
then
to
multiply.
always, yeah, you have to always substitute for sine and cosine first.
Okay.
Okay, now what is r squared?
Um, x squared plus y squared.
Good. Okay. This time you do want to get them all on one side and complete the square for both. So you're going to move the minus 2x left, pair it with the x squared, minus 2y left, pair it with the y squared, and try to complete the square there, please.
X plus 1 squared plus y plus 1 squared equals 2.
Good. Any questions on that?
No, that makes sense, but would we just leave it at that, or would we?
Yeah, this is the equation of the circle. But if you were to graph it, you would see that the circle, so it should have the equation of a circle. If you were to graph some of these other ones, they're equations of lines, so this should look like lines.
Okay. But we wouldn't like multiply, I mean, do the square root of both sides.
That only gives you the top half or the bottom half of it.
Okay.
Okay, let's take a look at 74. What is another way to recite? What is another way to rewrite cosecant of theta?
Sine over cosine?
It's cosecant, not cotangent.
Oh, 1 over cosine. No, 1
Try
over
again.
sine.
There you go. And what's the substitution for sine theta?
Sine theta is y over r.
Whatever. Good. So why don't you try solving this for y? Actually, not that much to do here.
X equals -5.
Um, there's no x. There's only a y.
Oh, sorry, y equals -5.
Okay, possibly better, but when you flip this, you get y. You get r over y equals r. When they're on the same side, they cancel. But what's left on the left side? One, right? And so yeah, it is y equals -5. Good. Okay, 73 is really similar. I'm gonna try that one for us, please. Really, really similar.
See it.
Yeah.
I got x equals 2.
Now, one of the things I think they're hoping you'll see here is the pattern. It's a lot to remember though. Like if it's cosecant, it's a y. If it's secant, it's an x. I think that's a lot to put on you as a student to try to remember that, but that could be, you know, something that they want you to remember out of this.
Yeah.
All right. So look at this one here. What kind of stands out to you as like the first um what would you first here?
Um, at first multiply that's the 2 cosine theta plus sine theta with r.
Okay.
So then it'd be 2x plus y equals 2.
Yeah. Yeah. I mean I was gonna write 2r cosine theta plus r sine theta, but that becomes y and x. Yeah, now can you solve that for y? It's a linear equation.
Y equals 2 minus 2x.
Yeah. Or minus 2x plus 2. So I'll finish that form. So do the same thing and solve for 75. I'll be right back with you.
Solve for which one?
75, please. All right, Christmas cookie drop off. Just what I need.
Um, I got y equals minus x plus 2.
Okay, that is correct. All right. Any other thoughts on these grouping of questions?
I don't think so.
Okay. Where would you like us to go from here?
Do you have any other questions similar to these?
Yeah, I can find a lot. You don't have any issues converting the other way?
We could do that too. That'd be nice.
It's up to you. I just ask you.
Could we do it?
Yeah, I mean, they're not that difficult, but it's they would have appeared earlier in this, but yeah, let me find some. So here's kind of a classic problem. All right. So you have the same, and the instructions would say to convert from rectangular to polar. So
Mhm.
you know that x equals r cosine theta, and y equals r sine theta. So you just substitute those in. So it's r cosine theta. Well, let me take that back. There's a couple ways to do it. You probably actually would want to expand these first. Let's do that first. X squared minus 2x plus 1 plus y squared plus 2y plus 1 equals 2. These all cancel now. And then you know that x squared plus y squared equals r squared. So these two make an r squared. And then you typically add, equals 2x minus 2y. Just moving that over to the other side of the equation. And that's when you would substitute these in. So it would look like this. R squared equals 2r cosine theta minus 2r sine theta. And then you cancel the r's.
Okay.
You get r equals 2 cosine theta minus 2 sine theta. All right, you ready to try one on your own? Be a lot like this?
Sure.
Okay. X minus 2 squared plus y plus 2 squared equals 8. You definitely want to expand first like I did.
Or cosine theta minus 4 sine theta, or R equals.
Is it minus?
Mm-hmm.
Minus 4 sine theta. Good. That's really good. Okay, let's do another type of problem. Um, let's say it's x y equals x squared over 5. The main substitutions here is x equals r cosine theta, y equals r sine theta. R sine theta equals r cosine theta squared over 5. That becomes r squared cosine squared theta over 5. Is that okay so far?
Yeah.
And then the question might be like, well, what do we do from here? You want to get r on one side. There's an r on both sides, so you can cancel it out. R, cancel with r. So now it looks like this, and I'm going to move the 5 to the other side. So it looks like it's 5 sine theta equals r cosine squared theta. And so you divide by cosine squared theta, and you feel like maybe you're done. Problem is that you should try to reduce this. Like, okay, it's cosine theta times 1 over cosine theta. Sine over cosine is tangent. 1 over cosine is secant.
Okay.
What do you think of that?
That makes sense. Yeah.
Okay, so let me give you a slightly easier one here. Well, man, not really easier. I mean, they're just the same, slightly different one. But let's do it. X equals y squared over 3. Why don't you try that, please?
I don't know if this is right, but I got 3 cotangent theta, cosine theta.
Cosecant theta.
Mhm.
Okay, that is correct. Okay, you want more of these other types though? We didn't really do one with tangent, which, and this isn't the best example, but so let's say your instructor does like tangent of theta equals 2. So we're not going back the other way, polar to rectangular. You do you remember what tangent is in terms of y and x?
It's sine over cosine.
Yes, but in terms of y and x, what is that?
Y over x.
Yes. All right. So how would you solve this for y?
How would I what?
How would you solve this for y?
Multiply both sides by x.
All right, so y equals 2x. So another type of problem you'll see here is like cotangent of theta equals 4, for example. And cotangent of theta is really 1 over tangent of theta. So how could you use what we did in the previous problem um, to solve for it, solve for y?
It would be cosine over sine instead of sine over cosine.
Okay, so it'd be like x over y equals 4. Can you solve that for x for us, please? For y, sorry.
Y equals 4 over x.
It's x over 4.
Oh,
Okay,
yes.
a couple of oddities that we hadn't looked at. So the graph of theta equals pi over 4 is this line right here, which has the equation line y equals x. Now, if you recall, the tangent of theta, right? Tangent of theta, tangent of pi over 4. What's the tangent of pi over 4 from your unit circle?
Um, one.
Is 1. And then what's tangent of theta in terms of y and x?
Y over x.
Okay, so can you solve this for y?
Y
And
equals
that's the same.
x.
It's the same as this, yeah. Okay, so let's really quickly here for our last problem, we're gonna do the same thing. Do you have a unit circle handy or not?
Yes.
Okay, so we're gonna take the tangent of both sides. Tangent of theta equals the tangent minus 2 pi over 3. Can you tell me the result of this on the right, please?
Minus 2.
Be minus square root of 3 over 2 over -1/2? Do you have something like that down?
Yeah,
Okay, what does that reduce to? What cancels?
2√3/2, which equals √3.
Just √3, so the tangent of theta is √3. Tangent of theta is really y/x. So y equals x square √3. All right, you got that down?
Yeah, that makes
Okay, I am unfortunately gonna stop here just due to the fact I'm not feeling real well. So I do hope this helped. It did work out really well. Another student needed to